Welcome. Today we have a flat earther that are going to teach us how to use a map.
I hope everybody's doing well. This is part 2 to the Gleason's map and how it is used. I'm going to show how to get distances, and we're going to do from Sydney to Perth and from Santiago to Sydney.
Oh dear, this will be interesting. Today we will have a look at part 2 from a video series from Flat Earth Tests that thinks he's are capable of proving that the Gleason's map is a real map and that you can use it for instance, measuring distances across Australia. And will he succeed? Let's start this dumpster fire.
But real quick, I wanted to show, because there's still a couple of stubborn mules out there who think the AE map it was derived from a globe. Well, here's some of the history. It dates all the way back to the ancient Egyptians.
The Gleason's map is a polar azimuthal projection, but it's obvious that the Flat Earth test don't understand what the azimuthal map projection is. Is when you place something in the center, it can be the poles or the place you are at. When the Egyptians made maps over the stars, they placed themselves in the middle of the projections. It was not a projection of the globe.
And it dates back to the 11th century and all throughout history, because it's the true projection of the world. I personally believe that it's blatantly obvious that whoever made the globe hijacked the information from an AE map.
Do you believe in unicorns too? Do you never thought of the fact that no one uses this type of maps, for instance for navigation at sea?
It's the only way to map a celestial dome onto a surface. You can't map a celestial dome, which is what they use for latitudes. So you can't use a 2D surface. It's not possible. So they used the globe. It was easier. And then people, I guess, started thinking it was a globe just because of that.
He obviously didn't understand the pages that he looked at. The Egyptians used this shape when they mapped the stars because they was in the center and the stars was surrounding them in the sky. So it's nothing strange with choosing that type or this type of projection for that.
But that's not reality. So you look and see who all's used this map. I mean, it's used by the USGS, by all radar, by military, for missiles. All the directions are accurate.
You don't use maps in radar. In modern system, you can combine the chart with the images from the map and the information from ISS and so on. But the radar itself don't use a map. I think that these fools get confused by the fact that most radars have a round screen. Why do you think it's round? You have the antenna in the center of the image, in the same way the Egyptians did when they made a star map. And in the military we don't use the Gleason map at all. We don't use it for navigations, we don't use it in our weapon systems. All our systems are based on a globe.
It's the logo, obviously, for the United Nations. But anyway, I mainly just wanted to show that the AE map came way before the globe. Whoever tells you different is either ignorant or lying through their teeth.
If you have more than 2 working brain cells, it's easy to understand that if you're going to make a map when you don't know how the world looks, you start from your position. You are in the center of the map. In the next part he will show how he thinks you're measuring distances in reality using a Gleason's map. I will speed up some parts of this.
In a previous video I used the 24-hour method because there's 24 longitudes, but I'm going to do it the conventional way in this video and just use 2 12-hour sections. So from the center of the map to the right edge is 0 longitude, or Greenwich meridian. It marks 0. Anything above that is east of Greenwich, and anything below it is west of Greenwich. And it goes all the way to the other side, which is 180. So you have east, you could go from 0 to 180 east of Greenwich, or 0 to 180 west of Greenwich. East being above, west being below. So the latitude lines are circles, and there are 12 main latitude lines that are 15 degrees apart. The red line is the equator. Anything above the equator goes from 0 to 90, and there are positive latitude. And below the equator, or the outside, is negative 0 to 90. And you also have the tropical Cancer and Capricorn. So let me show you how this works on the map. We start off right there at Greenwich, and then every line is 15, 30, 45, all the way to 180. So 0 to 180, and so that's east of Greenwich. Anything above is east of Greenwich, and anything below is west of Greenwich. It's the same thing, 0, 15, 30, so on, all the way to 180. So we'll find our city, and we'll start by measuring the longitude. It says that the degrees in longitude reduce to the sun time in minutes, and everything reduces to 60 nautical miles per degree. And that's why there are so many little lines here on the outside, because between every longitude, or every time zone, there are 60 minutes of arc. So for every 15 degrees, there's 60 minutes, or 4 minutes per degree of arc. So the main takeaway from this introduction is that this map reduces 60 minutes of arc to 15 degrees of longitude at 60 nautical miles per degree. So let's check distances. We're going to start with getting the latitude to Sydney, Australia. So to get the latitude of Sydney, there's 30 south, or negative 30 degrees latitude, and then there's 45. And we see cities in between 30 and 45 south latitude. So in between these latitude lines, we're going to make a little mini scale with 15 individual degrees to get easy and accurate measurements. I actually meant to use the other scale, but it doesn't matter. It's the same principle here. It used to be built in as a hand on the Gleason's map, but instead of cutting it out, we're going to transfer it onto a piece of paper. So I'll show you in just a second. You see, between 30 and 45 degrees, there's 15 little lines and there's 5 bigger lines. We'll mark between 2 latitudes and we'll mark 5 big lines. See how it's labeled here, 3, 6, 9, 12, and 15. Then we'll fill in the tweeners, the 1, 2, the 4, 5, the 7, 8, so on. Or you could just take the piece of paper and put it over the scale and trace it. And you can hang on to it, so every time you need to get a city's latitude accurate within a degree, then you will have it. So I'm going to show you how this works. So now we're going to locate Sydney, and we're going to locate the nearest latitude line, which is 30 degrees. Then we're going to set our scale down and count the individual degrees. And we get 1, 2, 3, 4. So Sydney is 34 degrees south latitude, or negative 34 degrees south latitude. Now we're going to go and write down negative 34 degrees for Sydney's latitude, and then we're going to go on to the longitude. Now we're going to use a string line for longitude. Make sure it's long enough to make it out past the edge. Also make sure it's perfectly centered. Then you want to line it up exactly with Sydney, and you want to mark it, and it's 1 degree past the 150th east longitude. So that's 150 degrees east of Greenwich. So I circled where it's marked on the map. It's a little hard to make out here. You can count over from Greenwich if you'd like. Now we're going to record our longitude. So we have 34 south latitude and 151 east longitude. Next, we will do the same for Perth, and then we will follow Gleason's instructions and calculate the distance. So we've located Perth, and we got our little scale. We got 15, 30 degrees, and a little past 30. We're going to line up our little scale, and we get, let's see, 1, 2 degrees past 30. So 32 degrees south latitude for Perth. Now for the longitude. So we pull our string, and the nearest longitude is 105 east, and then we got 110, 115. Yeah, 115 east longitude. So now we can get the distance between Sydney and Perth. So it's negative 32 latitude and 115. So how many degrees are these apart? So there's Sydney, and the longitude from Sydney and the longitude from Perth. So we subtract 115 from 151, and we get 36 degrees. So 36 degrees times 60 nautical miles is 2,160 nautical miles. If we convert that into kilometers, it's approximately 4,000 kilometers.
Let's measure the distance on Google Earth. Oh dear, how can it be 700 kilometers shorter? And if we take the car from Sydney to Perth, what is the distance? Oh dear, it's shorter. And look, it's not even a straight line. How can this be?
So not 5,000 miles. That's not the way the AE map works, b-ball. So now we're going to check the distance between Sydney and Santiago. Since we already got the coordinates for Sydney, we're going to do Santiago. And I've already showed y'all how to do it. So I'm just going to skip to the results. So for Chile, we have 33 south latitude. And for longitude, it's 71.5 west of Greenwich. So 71.5 west longitude. So we have 8 full longitudes. So 8 times 15 degrees is 120. And then from Santiago, we have 3.5 left over. And then for Sydney, we have 14. So altogether, that's 137.5 degrees times 60 nautical miles is 8,250 nautical miles to do flat Earth circumnavigation between Sydney and Santiago. That's roughly 15,279 kilometers.
And once again, he gets the wrong number. It's not 15,000 kilometers, it's 11,000 kilometers. And why do he get it so wrong? The reason is quite simple. He don't use the correct method to calculate distances using longitude and latitude. It's the Eversyn formula you should use, but he's a flat earther, so I think that one is too complicated for him to understand.
So it ain't no 30,000 miles. This is how it works. This is according to Gleason's instructions. So if you believe the globe, then that flight does about between 400 and 450 miles per hour. Which I don't believe for 1 second, because they're in some of the fastest jet streams down there. So on a flat earth, they're doing about 650 miles per hour. Which one seems more realistic? I'm going with the Gleason. I will have one more part to this, but thanks for watching.
So that distance is 15,279 kilometers according to him. And let's measure the distance to me up here in Sweden. 15,385 kilometers. So according to this flat earth genius, this distance is 15,279 and this 15,385. Is it anybody that see a problem with this map?
Destroy.
I'm not sure if Brian, or Flat Earth Test as he calls his channel, if he's honest or only stupid, because it's so obvious that this map don't work. They don't have a flat earth map, but still he and the rest of the flat earth gang thinks they are experts in navigation. That's hilarious. Oh dear. Editing Arctic here. I've received some comments about my collecting money for buying drones to Ukraine. I have had comments where people feel bad that they don't have money to donate. First of all, I don't want people to donate if they don't have the money. And one thing more, you don't need to donate big money. If every of my subscribers donated $1 using PayPal, I could buy 2 kamikaze drones. So every donation is important, big or small. Thank you for watching, hope you liked it. Become a member, subscribe or come back next time I'm showing a video. Have a nice day, see you soon, bye.